we shall take the first and the second derivative using the product rule. Not one example, but two, because how do we get the second derivative? You take the derivative of the first derivative. Over and over again, over and over again. On this one, unlike the last one, we can't simplify the expression and not use the product rule. This one we have to use the product rule. What was that product rule? That was this guy. If you're taking the derivative of a product, you use the product rule. It's the derivative of the first times the second plus the derivative of the second times the first. And here we go. We've got two functions I'm gonna let the first f be x to the 5/2, and my g gonna be e to the x. What's next? We're looking for y prime. Y prime. That's gonna be the derivative of the first times the second plus the derivative of the second times the first. Boom! Let's go and take those derivatives. What's the derivative of x to the 5/2? Yeah! We take that 5/2. That's ugly. Make that nicer. We take that 5/2 x, and then we subtract 1 from 5/2, which is 3/2. And then I have this e to the x still there. And then we'll add to it the derivative of e to the x. What's that? Oh, yeah. Times the first. Yeah. So that's the first derivative. Do you want to take the second derivative from there? Or do you want to clean it up? I say we clean it up. When we're doing this fancy factoring, we're going to take out the smallest power of x, take out the smallest power of x, and we'll take out that e to the x also. So taking out that smallest power of x, the smallest power was x to the 3/2. And we're pulling out an e to the x also. And then left on the inside, we're going to have, oh, looks like 5/2. And we pulled the rest of that stuff out. And then plus. So now when we pull out our 5/2, or when we pull out our 3/2, what is this term going to become? We're like x to the 3/2 times x to the what? That's not a 2. Ah, go back. Go back. X to the what is going to equal x to the 5/2. What I'm asking really is, what do I add to 3/2 to get 5/2? 2/2. And then I have, okay. Psh, that's 2/2? What's 2/2?
1.
Okay, so then that's what's going to be left over in there. I guess I could have just left it. 1x. Oh! Maybe we should have left it like it was. Because now, when we're taking the second derivative, dirty. we're going to have the product rule inside the product rule. What? I got 3 functions there. 1, 2, 3. So let's group them 2 by 2. Ooh. Let's group them 2 by 2. How? Which one do you want to be the first and which one do you want to be the second? Okay. Fine. I'll do it. I'm just going to let this one be my first and this one be my second. So, when we're looking for y prime, it's the derivative of the first. Y double prime, because this is y prime. Nice catch. Derivative of the first times the second. Plus. It's all on the same line. The derivative of the second times the first. Oh, boy. Now notice, in our second piece, when we were taking the derivative of the first times the second plus, in here, derivative of the second, we're going to have to use the product rule again. Oh, boy. I know. Double dose of product rule. 2 examples in 1. So let's just take care of that first part. Boom. What's the derivative? And when I say first part, I mean this. What's the derivative of x to the 3 halves? 3 halves. 3 halves x to the 1 half? Okay. Skip, skip. That's y prime prime. 3 halves x to the 1 half. That was the derivative of the first. And then we're going to multiply it by the second. What was the second? E to the x. 5 over 2 plus x. Bam. Bam. Okay, so that was the derivative of the first times the second. Let's go back and let's get that piece. This piece. Somebody copy that down so I can write it down on another page. Yeah, let's put it right here. This is piece 2. What was piece 2? Oh, that's not bad. Okay, so we're just worried about this piece. So I'm going to let this be f and that be g. So if I'm looking for the derivative of that there c, it's the derivative of the first times the second. plus the derivative of the second times the first. Which was e to the x. And then it is important to make note that all of this is being multiplied by that x to the 3 halves. But that's there, not here. We're taking the derivative of that inside. So, the derivative of e to the x is e to the x. It's still going to be multiplied by 5 halves plus x. And then, the derivative of the second, boom. Derivative of 5 halves. What's the derivative of a constant? You're out of here. Oh. So then that's going to be e to the x? Well, this is turning out much nicer. And then that's still multiplied by that x to the 3 halves. Let's go ahead and factor that out and make it nice. So then I pull an e to the x out. That's not nice. That's ugly. You're ugly. So we have x to the 3 halves. Pull out an e to the x. And then, what's left over on the inside? Is it 7 halves plus x? 7 halves plus x? Or x plus 7 halves? Some of you guys are like, where did the 7 halves come from? Well, there's a 1 in front of here. There's a 1 in front of the e to the x. So when I factor out an e to the x, I have 1 plus 5 halves plus x. And then 1 plus 5 halves is 7 halves. Anyways, let's take this part. Boom. Because that was the derivative of the second. The second derivative. It was a derivative inside of a derivative. Okay, let's try to figure out where we're at. Ah, that was that piece. So, we took the derivative of this first piece. Boom. And we put that here. Let's see. Yeah, that's what that is. Good. And then, on another page, we took the derivative of the second piece. That was here. Let's put the two pieces together. I know that we're working on several panes. Yeah, that's right. So that's x to the 3 halves, e to the x, x plus 7 halves. And we're going to put that in here. That's plus x to the what? I'll do it. X to the 3 halves. E to the x. And then that was times. Is it x plus 7 halves? Oh, sure is. Now let's do some sick factoring. We're going to pull out the smallest power of x again. Oh, that's that. Before we go any further, how many terms do I have here? I have 2 terms. What? I have this term, and I have this term. But what about this? That's a sum inside of that first term. So I only have 2 terms. So I'm looking for things in common. I'm pulling out my x's. So I take out the smallest power, which is x to the 1 half. Do it, boy. So I pull x to the 1 half out. I also see an E in common. Ooh. So I'm going to pull that E. Now we talk about what's inside. I'm still going to have this 3/2. And it's still going to be multiplied by that 5/2 plus x. Because those are the leftovers after we pull out x to the 1/2 and e to the x. Now let's talk about what's left over on the other term. So if we pulled an x to the 1/2, same trick we did before. Same trick we did before. If we put 1/2 plus what is 3/2? 2/2. So then 2/2 is the same thing as 1? Okay. So if we pull that out, then we're going to have just 1x left on the inside. So then that's where that x comes from. And then it's still going to be multiplied by x plus 7/2. Now this example is getting way long, but that's okay. Let's clean this up. Because we're looking for y prime, fully factored form. That's x to the 1/2 e to the x times. All right, that looks like 15/4. 15/4. Three halves x and 7/2 x, that's 10/2 x, that's 5x. What was that? That was the 3/2 x and the 7/2 x. So 3/2 and 7/2 is 10/2, right? Okay, so 10/2 is 5x. And then looks like we got an x squared right there. Oh, tell me that factors. Factors of 15 and 4 that add to be 5. No, factors of 15 and 4 that add to be 20. 15 and 4. 15 times 4 is 60, right? Factors of 60 that add to be 20. Does anybody know any factors of 60 that add to be 20 just off their head? Are there any factors of 16 or factors of 60 that add to be 20? I could use some help. This video doesn't need to get any longer. Fine, I'll do it. Whatever. Your face. 1, 2, 3. What am I doing? It'd be a lot easier if I could get a little help. You can't be helped. Factors of 60. That's 1 and 62 and 30. That's 3 and 20. Math is not a spectator sport, people. I need you to get in there and get dirty. Does 4 go into it? 15. 4 and 15. Does that add to be 20? Ooh, it had to be 19. It's close, though. 5 and... Oh! Now, see, now we can stop because these were 20. We were over it. Or that was 23. We were over it. That was 19. We were under it. And I'm over it. Because... second derivative of x. And I know. Let's build a bridge so we can get over it.